Hey kids, welcome to Unit 3, Lesson 7, Polymorphism, exercise number 2. Looks like we got the code from the last lesson here, but we're going to use our worksheet investigating polymorphism to make some modifications. We've already looked and discussed the code in exercise 1. Let's jump into the worksheet and see what we have to do. Using the space below, draw a visual representation of shapes list 1D array in Java Lab. Include the index for each element. Our array is my shape, my rectangle, my circle. That's what we have to visualize. We have 3 elements. We want to put a table in that has 3 columns, 2 rows. First one's going to be my shape, my rectangle, my circle. Index 0, 1, and 2. Look at the shape, rectangle, and circle classes. What method is overridden? Why do you think it's overridden? We talked a lot about this in our last video. We're overriding the calculate area, and this is a lot like what we did with the toString. We're overriding a method. And how did toString work? Well, each method was calculated at the subclass level, or when that method was run. Same principle here. Calculate area is only going to be calculated when that object is called. So we'll say calculate area, and that is because each method will only calculate when called. We're going to update the calculate area of shape to return 0, 0. What do you think is going to happen? Let's go look at the code. And this time, we're going to change 4 to 0. And that's the width. Remember, we passed the width down to our rectangle and to our circle. That means 0 times 0 should give us 0. 0 times our height will give us 0. And 3.14 times 0 should also give us 0. I think any number multiplied by 0 will return 0. 0 is a width passed to all methods. We're going to run the code, and we're going to see if that's what happened. Let's go ahead and run it. Let's change our 4 to 0. And let's run. Different output than I thought. Only the first one changed, not the second two. That means only the shapes calculated area changed to 0. That is because calculate area is overridden in the rectangle and circle. So I was wrong here. 0 isn't passed to all methods, it's being overridden in each method. Again, another example of polymorphism that we've already seen. We're going to update calculate area of circle to return 2. Predict what will be printed. Well, if we're only doing it in the circle, I think we're going to get our 0 from our last lesson, 18 because we haven't changed rectangle at all. I think circle is going to be 2. Our output should be 0.0, 18 because that's unchanged, and we're only overriding the circle method. Let's see if we're right. We're going to go to our circle, and we are going to return 2. That means I'm going to get rid of all this and just return 2. Doesn't matter what's in it. Let's run and see if we're right. And it looks like we get that output because we only change calculate area for the circle class, not the parent class or any of the other subclasses. Pretty neat. Again, polymorphism at work. What are we going to write? Only the circles calculate area change to 2.0 because circle is a subclass of shape and calculate area is in circle. Ooh, look at all those spelling errors, kids. Calculate. Update the array declaration so shape list is an array of rectangle instead of shape. Predict what will be printed. I think we're going to get an error because we're going to have a different structure, and because of that, we're going to get different readings. So I think there will be a compiler error. Not sure which one yet. Let's go ahead and run it and see. So the declaration, we're declaring our array in the shape class. Now we're going to change it to the rectangle class. That means shape doesn't have access. Because remember, rectangle is a subclass of shape. We can get stuff down, we can't get stuff up. Well, let's see if that's right. And since my shape extended to rectangle and circle, not only did it affect shape, it also affected circle, which was getting all of those attributes and methods from shape. So we got two errors on this. We got an error, incompatible types. Shape cannot be converted to rectangle because it's not a subclass. Got a spelling error there. We got another error, incompatible types. That is circle, which was a subclass of shape, cannot be converted to a rectangle. And why'd that happen? You cannot assign a shape in a rectangle array because shape is the superclass. And for circle, circle is a subclass of shape, not rectangle. We've got a little grammar here, not a rectangle. 9, declare and initialize a new shape array by adding the following code. Looks like we're creating a new array, second shape, and it has 3 indexes. At our first index, it's going to be 2. At our second index, it's going to be a rectangle at 2, 4. And our third, a circle at 2. And how is this similar to syntax used for creating the shapes list array? How is it different? Well, it's almost exactly the same. This time we're declaring it blank instead of initializing it with values. So I don't think it's any different, and I think it's going to work pretty much the same. The only difference, in the other one, we declared it with values. This one, it's declaring it empty, then adding values to each index. Well, let's see if it works like that. Let's copy this and head back over. Don't forget to change your shape list array back to the right class. And let's go down here and add that code. This should create another array called second shape with 3 objects in it. Well, let's see if we're right, kids. And it looks like we didn't get any errors. How is this similar? Well, the array is declared using the same syntax, but it is initialized to contain null elements in each position of the array. Each position in the array is then modified to contain a reference to a different shape object. The only way to access these objects is now just through the array. There is not a separate reference variable to access these objects. Clean up our spelling here. And we have one last thing to do. Declare and initialize another shape array by adding the following code. Third shape is a new shape with one parameter 2, a new rectangle with 2 parameters, a new circle with 1. How is this similar to the syntax used for creating shape lists in a second shapes array? How is it different? Well, I think it's a lot like the shapes list array. We're initializing one with values. This, though, we're initializing it not only with its values, but the parameters we're passing along. And this is really a neat way we can show how polymorphism works, because we're reusing all of these methods and declaring them all in one single line in an array. Let's copy it over and see if we get any errors. Let's copy, come down here, and we'll declare our third type. And hopefully we won't get any type of errors. I think it's going to do the same thing as above. We're just declaring it all in one line now. Well, let's see if we're right. Didn't get any errors. That's pretty good. What am I going to write? Well, the array is declared and initialized using an initializer list. Instead of creating a reference variables for each object and then setting each position in the array to those reference variables. New shape objects are instantiated at each position. The only way to access these objects is now just through the array. There is not a separate reference variable to access these objects. Look at all those spelling errors, kids. I know. Terrible at spelling access, aren't I? So all of these three have the same thing in common. They're all overriding that calculate array method. We declared the array 3 different ways. One, we declared the variables with values to be passed along. Then we created the array, then populated the array at each different position. And finally, we declared the array and the parameters in one line along our array. And this really shows 3 different ways we can use our array to overwrite that calculate area method. And overall, a very neat way of demonstrating polymorphism, or from one is many. The key takeaway from this lesson is further diving into this idea of polymorphism. Specifically, this one is looking at how we override methods in different subclasses to get different answers. So we don't have to write a different area for rectangle, circle, or shape. We can reuse the same one from our parent class and override the method every time it's called. And that's really the central idea of polymorphism. From one is many. Hopefully this video helped you understand polymorphism a little better. As always, if you have any questions, come see me. Otherwise, I'll see you in the next lesson. See you later, kids. Bye. Bye.